Today's lesson, I'm going to be going over electron orbitals. Okay, so a lot of times whenever you hear about atoms or see images of atoms, you're going to see something similar to this here. And so that doesn't really depict clearly where the electrons are orbiting within the atom, okay? And then here, this model here, this, if you remember, is our Bohr model, okay? It's kind of helpful in that it kind of shows the different shells or energy levels that the atoms can be in, but it doesn't actually give a accurate description of where those atoms or those electrons might be whenever they're orbiting around the nucleus, okay? So this area over here, this is a better depiction of the different areas in which the electrons can be found at that given point. Okay, and so each of these different energy levels gives us a different orbital. Okay, so each of these are called orbitals. So here we have the orbital, and this is the s orbital. Okay, this second line is the p orbital. The third is the d orbital. And then the last is the f orbital. Okay, and we're going to kind of talk about the different sublevels for each of these orbitals as well. Okay, so you can see they have them broken down into the different sublevels, and then those all fit together to show the areas in which the electron might be found. So each sublevel of an orbital can hold 2 electrons. Okay, so we're going to talk about each of these orbitals. So for the s orbital, it can hold 2 electrons. Okay, so it has 1 sublevel. Okay, and we'll kind of get into how to kind of set up the different sublevels once we kind of get more into electron configuration. Okay, the next one, the p orbital, can hold 6 electrons. Okay, and so because each sublevel can only hold 2 electrons, it means that this has 3 sublevels. Okay, the next one, d orbital, can hold a maximum of 10 electrons. So it's going to have 5 sublevels. Okay, and then the last one, the f orbital, can hold 14 electrons. So that means it can have 7 sublevels. Okay, an important thing to note too is that in the suborbital, 2 electrons are actually spinning in the opposite direction from each other. Okay, so every once in a while they'll meet, but they are going to be spinning in the opposite directions. So if we look at the periodic table, if you remember for our energy levels, okay, our period numbers give us the electron levels. So here in period 1, all of these elements, so we have 2 of them, they're only going to have 1 energy level. We have 2, 3, 4, 5, 6, and 7. Okay, and then these 2 down here, they actually fit right here in these sections. So this pink, light pink is supposed to fit here in the 6th period, and then the darker pink is supposed to fit here in the 7th period. Okay, so those are the different energy levels that we have. Okay, so if we write out the energy levels, not all of the orbitals are actually available in each energy level. And we're going to kind of break down the periodic table to kind of show the breakdown for those. Okay, but first we can kind of draw out this pattern that shows us how the energy levels are done. Okay, so if we look for energy level 1, so N1, so this would be this first period, okay, it only has an S orbital. Okay, period 2 has S and P, so we have energy level 2, and then S, energy level 2, and then the P orbital. For 3, we have S, P, and D. For 4, we have S, P, D, and F. For 5, we have S, P, D, and F. For 6, we have S, P, D. And then for 7, we only have S and P. Okay, and it'll make sense why we have certain ones for each when we kind of look at the periodic table and the patterns that we see with that. Okay, so you'll notice there's some arrows that are kind of going through each of these levels. So this shows us the pattern in which the orbitals fill. So they don't just fill, we put 2 in the 1s, we put 2 in the 1s, then 6 in the 2p, then 2 in the 3s, 6 in the 3p, then 10 in the 3d. Okay, it doesn't go that way. The pattern is it goes, fills the 1s, then it goes to the 2s, then it goes to 2p, then to 3s, then to 3p, then to 4s, then to 3d, 3p, 5s, okay? And so if you remember back whenever we were talking about the energy levels, and I said that the first energy level, it can only hold 2, okay? So if we see here, it only has an S, so it makes sense it can only hold 2, okay? The second energy level, I said it was full when it had 8, okay? So we have 2 electrons here, and we have 6 electrons here, so 2 plus 6 is 8, right? And then if you remember for the third orbital, I said it was a little different. I said it could hold a total of 18, which if we look, we have 2 plus 6 plus 10 would be 18. But I said for the purposes of whenever we were doing the Bohr model, it would be full at 8. Okay, the reason for that is because whenever we're going through this pattern of filling, it fills the 3s, so 2 electrons, then it fills the 3p, so 6 more, so that's 8. Then it jumps to the 4s level, and it would fill in 2 before it jumps back down to the 3D level and fills in the remainder 10. Okay, so it gets a little jumbled there. You're not going to need to know that unless you go on to kind of more advanced chemistry courses like in college and stuff like that, but I kind of just wanted to touch base on that just so you kind of knew why the third energy level was kind of different there, where I said it can hold 18, but it gets filled at 8 because the other 2 go get in the fourth energy level, and then the remainder get filled in the third. Okay? So if we were going to do the electron configuration for these different atoms, if we were looking at boron, if we look, is here. Okay, it has 5 protons, and all of these we're just going to assume are neutral. So because it has 5 protons, it's going to have 5 electrons. So because it has 5 electrons, we're going to start filling in the energy levels, okay? So to start, we're going to start in the 1s orbital, okay? So for the first one, the s can only hold 2. So we're going to have 1 electron, and it's kind of shown with like a half arrow. So we have one that's going spinning upwards, and remember when they pair together, they're going to be spinning in opposite directions. So we show the other one with a downward spin. Okay, so now we have 2 electrons, but boron has 5. So the 1s here is already filled up. So we have to go to the next one, which is 2s. So for 2s, we're going to have one that's spinning upwards and one that's spinning downwards. Okay, so that one's now filled. So we have 1, 2, 3, 4 electrons. We still need one more electron. So if we go through the pattern here, we're going to go back up to 2p, and we're going to fill in the one electron that we're missing. Okay, so you'll see that this orbital isn't filled, but we now have reached our 5 electrons. Okay, so this is the image for the electron configuration of boron. Okay, for the next one, we have calcium. So calcium is the 20th element, meaning it has 20 protons, and because it is neutral, we have 20 electrons. Okay, so we're going to start again at the 1s phase, and it can hold, the s orbital can hold 2. Okay, so each of these boxes basically can hold 2 electrons. So we're going to put them in opposite directions. So we have 2. Then we're going to move on to the 2s. It can hold 2 as well. Okay, now we need to move on to 2p. All right, for this one, okay, we have 2. We got to get to 20. All right, you would think that this is how we start filling them in, okay, but it is not correct. All right, and this is called the empty seat or empty bus seat rule. Okay, if you were to get on a bus and there was someone sitting here in this seat, you probably would not go sit next to them. Okay, you wouldn't go do that. You would go sit in the next empty seat. Okay, because it's a stranger, you're not going to sit with them. Okay, same thing with electrons. They're more likely to go and sit in a different sub-level. Okay, and the reason for that is because electrons, they do have the same electric charge. They're both negative, so they're going to repel each other. So they're going to fill the different sub-levels, trying to space themselves apart from each other before they start pairing up in the same sub-level. Okay, so as we go through this, we're going to put in our 3 upwards ones. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. Okay, so now we have to go to the 3s level, because if we're going through this, we've gone through 1s, 2s, 3p, and then now we're in the 3s. S can only hold 2. So 11, 12. Okay, and then we go to 3p. So this has been checked off. So 3p, 13, and then we're going to skip the seat. 14, 15, 16, 17, 18, and then 4s can only hold 2, 19, and 20. Okay? So it's important to note that whenever you're doing the 2p, so whenever you're doing the orbitals P, D, and F, you want to make sure that you are filling in all the suborbitals before you start pairing up the electrons, okay? So if, let's say we were doing, instead of boron, we did carbon, which has 6 electrons, okay? The correct way to do it would have been this, if we were doing carbon, which has 6. Okay, it would be incorrect if you would have wrote it down like this. Okay, that would be incorrect electron configuration, because remember, electrons are going to try and space themselves out before they actually pair up together.